Welcome to Science with Miss Steph. Today, I deconstruct the lava lamp demonstration. So, just to give you an idea, as far as you all wondering if you're wanting to try to attempt to do this with me, you need, that would have been bad, it almost fell off my table. You need a water bottle. And yes, notice this is a disposable water bottle. Y'all know how I roll. I will reduce, reuse, recycle water bottles. I used that earlier this week for something else. Okay. So paste. You're gonna need a water bottle. You need 3 different cups. Do you see it? Okay. And I'll tilt you, Facebook too. You need 3 different cups. Y'all see? Okay. 3 different cups. You'll need water. Okay, one of your cups you want to have water. One of your cups needs to have oil. You need 4 of these. 4. Thank you for joining. Okay, let's hang out today, y'all. We got a lot of people on the call. We're gonna have a good time. Okay, this is a classic, but I'm telling you, this classic is fun and there's a lot of science behind it, and it's just cool. Just stay with me. Okay, and so 4. These come in 2 packs. Okay. Do you have to have brand name Alka-Seltzer? No. Do I say Alka-Seltzer for a reason? Yes, I do, just because it's the thing that makes sense to people. So, okay. Cool. It looks like we've got somebody. Yes. Cool. All right. This is what we're gonna. Hoping I won't be on too long today, because sometimes I just talk. You guys know that, right? But yeah, we're deconstructing the lava lamp activity. So as you know, the lava lamp activity is just a famous classic one because everybody thinks lava lamps are really frankly cool, right? You have this situation to where you're getting this bubbling effect, okay? Now, a real lava lamp, a lava lamp that you plug into the wall, okay? Remember back in the day, okay, maybe not back in the day, but a few months ago, summer 2020, I did another version of this activity. Okay. This is a remix of a remix of a remix. Okay. And I talked to you guys about how my dad had a lava lamp growing up. Like I had a lava lamp. Well, it was my dad's, but y'all know what I'm saying. It was really cool. Those are actually a mix of 2 liquids that have 2 different densities and 2 different boiling points. Okay, and you plug it into the wall, and the bottom substance, the substance that's typically like the darker color, is actually a waxier situation. And so, as we all know, wax at room temperature is solid, but then you start to heat it up and it bubbles up. That's how it works. Okay, and then the substance in there that's the top, that's again usually the lighter color, and the stuff that looks like it's liquid all the time, that stuff is usually like some type of oil of a low density and that type of thing. Anyways, that's how that works. This thing here, right, the classic lava lamp activity is actually based on a couple of things. Density, say it with me, density. Did you say it? Density. Okay. And the idea, or rather the reality, the real scientific fact that water and oil do not mix. Hey, girl. Are the kids with you? Hi, kids. Okay. Water and oil do not mix. Okay. And so the reason that water and oil do not mix is the fact that water is, water is, okay, hydrophilic, right? Water likes itself. That's a way to say that water likes itself. Okay, water likes itself. And there are other substances that do, which is why we're able to add certain things into the water for this. Also, oil, chemically speaking, okay, is this type of oil less dense than water, so it will float on top of the water, and you get that layered situation. Okay. And the oil is what we call hydrophobic. Phobic, as in, right? Like, y'all know what a phobia is. Like, like it's scared. It does not like, okay? It does not like water. So chemically speaking, oil and water do not mix. They will never mix unless you help them. Okay? And in this activity, we basically capitalize, yes, on the fact that oil and water don't mix. And then we also capitalize on the fact that our tablets, our Alka-Seltzer tablets, okay, our Alka-Seltzer tablets make water fizz. Our food coloring is hydrophilic. It likes water. Water likes it. It mixes in. So in the end, we get this really cool thing. So let's go ahead and rock with this of the cups. Cool. Fabulous. Okay. So you'll find out later why I asked you to have 4 of these. Okay. You see 3 cups, but you'll find out at the very end why we're doing 4. Once again, I'm Miss Steph. Thank you so much for joining me. My apologies if you're not able to comment over on Facebook. You're welcome to join me over here on Instagram. Or you can like send TFE a DM or whatever if you have like a question, that type of thing. Okay. So first thing we're going to do is add some of our oil, about half of the cup's worth, some of our oil, okay, to our middle cup. The middle cup had nothing inside of it, okay? So this is our lava lamp deconstructed, right? So this is my deconstructed lava lamp. The parts that we put inside of the lava lamp activity, typically we would go straight to the bottom, right? But today we're not doing that. Today we are taking advantage of the fact that we want to learn what happens when we add our add-ins, which is the food coloring, and our fizzy tablet, aka our Alka-Seltzer, aka the antacid, our fizzing antacid. Okay. And we can talk a little bit about what's inside of the antacids in a little bit. Okay. When I add it. So the first thing I'm going to do is add my gel food coloring. What makes this gel food coloring as far as what's inside of this? Okay. Inside of this, you have corn syrup. Corn syrup is the reason why you get this kind of the gel kind of situation. Okay. And some other things. There's some other chemicals inside of here. All right. So I'm going to add just 1 drop or glob per se to each of these. Now you should have noticed as soon as it hit the water, that's what's inside of this cup, the cup that's on the far end, it dispersed, right? So water, okay, and food coloring easily mixed together. Water and oil, however, like I said, oil is hydrophobic, and this oil is less dense, okay, less dense than the water. And so that's the thing that's floating. And then you notice that the food coloring, when it passed through the oil, it picked up like kind of a layer of the oil. And so it is starting to dissolve. It's starting to mix in, but not all the way because it's got the little layer of oil on it. So it's slowly mixing. Over here, hi. Over here, we've got oil and food coloring. You notice the food coloring does not disperse, does not mix at all. Where with the there we go. Did I wave at you? So once again, welcome to Saturday Science with Miss Steph. Science with Miss Steph. Hi. Oh, yeah, it's fine. I'm Miss Steph, just in case you're wondering. Okay. And today we're doing the deconstructed lava lamp. Okay. So for those of you who have littles, right? Little ones or little ones that are watching, okay, you might want to just go ahead and start adding these substances into the water bottle, right? For them. But for my olders who really want to understand the science behind it, you can do it the way that I'm doing it, right? I'm taking it apart and I'm demonstrating for you how our two add-ins, okay, how our two main reactive substances, okay, our Alka-Seltzer and our food coloring, react and interact chemically with our three setups. Okay, this is 100% water, this is 100% oil, and then this is my 50-50. This is my thing that's proving to you what my two add-ins actually interact with, what they really react with. Okay, isn't that cool? Come on now, people, y'all know this is cool. Y'all know this is cool. Now let's find out what happens. I'm going to put one of these tablets to the side. Actually, let's use one of the broken ones for that later. Okay. Now let's find out what happens, okay, or which of the substances the tablet reacts with. Right? So we're doing this activity to let you see. So now I've got inside of with the oil and food coloring, this is what I get. As far as I'm concerned, that's not too exciting. I mean, it's a little something. And then now we've got our food coloring, water and oil together. I'm actually going to do that last. Let's see what happens when we add our Alka-Seltzer tablet. Yes, it's broken because, y'all know how I broke it. Okay. Let me put this closer so you can see it. Okay. First of all, you see that the fizzing is happening very quickly. I'm not really getting a whole lot of up and down bubble action. It's just fizz, right? Let's observe. Let's find out what happens. What happens when I take my tablet, my faux Alka-Seltzer tablet, okay, my store brand, store bought Alka-Seltzer tablet, yeah, and put it inside of here. Before, hi. Before I do that, I want you to take a few moments to predict, make a hypothesis. And for those of you who are able to comment, please put in the comments what do you think will happen. I'll give you a moment. What do you think will happen? You can write your hypothesis in like a direct what will happen kind of statement, or you can use it as a comparison as what you think will be the difference between this compared to what we already did. But what, 5, do you think will happen? Write that in the comments before I do it. 4, I'm going to do it. 3, what do you think will happen in this particular cup? For those of you who are familiar with the lava lamp demonstration, for those of you who have been watching what I've been doing. 2, and 1. Here we go. Boom. So do we notice that this is a bit slower? Or rather, it looks slower anyway. And you see the bubbles, right, are going, you can see this up and down action. And now you're getting the actual lava lamp type motion, right? Where you see the darker liquid is going up. Okay, the darker liquid is going up. And then now it's going to start to drop down. It's going to go up and go down. And we know that the darker liquid is made out of food coloring, in this instance, red food coloring. Hey, shout out to Valentine's Day and whatnot, and red t-shirts. Okay. The red food coloring is letting us see the reaction. It helps us really visualize the reaction. Okay. So the fizzing happened here. Thank you for your comment, Just Add Skills. Thank you for your comment. Right. So this is what we're getting. And you notice the reaction is still happening. Whereas when we put it in just water, the water and food coloring, it was like and done. Okay, but this reaction takes longer, and so you get a chance to really watch it and observe it and see it. Okay, once again, Miss Steph here. Thank you for joining me for Science with Miss Steph. And before we log out, I'm going to show you what it looks like when I mix all three of them inside of the water bottle, right? And not only do you get a cool reaction, you're able to see it better. You're able to really observe the reaction because you have more space. Okay. Notice I'm also not going to fill the bottle all the way up because this is a gas producing reaction. After we add our tablet to our container, gas will be produced. And then when I put my top on, okay, I'm going to like capture gas inside of here. And then when I get ready to take my top off, I don't want it to pop. Okay. So I don't want my bottle completely full because I increase the pressure. All right, like I said, this activity and this explanation is for everybody, okay? The activity is perfect for my littles and for even my high school level scientists. You all are probably learning about chemistry and different chemicals and the differences. You're learning right now in school, most likely, the differences between water, okay, and oil, right? Between our hydrocarbons versus our dihydrogen oxide. Yeah, fancy name for water. H2O. H2O. Okay. O2 would be our peroxide. Okay. So just making sure we're focusing. Now, do we feel like we're ready to add? Are we ready to add our chemical? Our last chemical, right? Our fourth tablet. And as you see, I've got it broken up so that it's easier to get to the bottom. All right. It's just a regular cap. That's all that is. That's all that is. Then top on tightly. And we now have, after having our deconstruction conversation, we now have our properly constructed lava lamp. Yes, I know, it's cool. I told you it's cool for me too, even though I've been teaching this activity for years. I've been doing this activity with students. But it's really exciting. It's really cool. I mean, the different chemicals that are involved in this are amazing. Okay. So I'm going to put this to the side just for let's put it to this side so that y'all can still see it over here on Instagram. Okay. And then I'm going to grab my box of antacid tablets. And we're really going to learn and mind blown. Let's find out what's inside of these antacid tablets and why they even create the effervescence, which is a fancy fancy name for just bubbles. Okay. That's all it is. All right. So on the back, if you see the active ingredients in a medication, that's the stuff that does whatever you want done, okay? And if you have an upset stomach, right, you're wanting the acid to calm down. And so you need to fix the pH levels in your body. Well, not your whole body, but specifically in your GI tract. All right? So inside of here, okay, we have aspirin, which is a pain reliever, okay? Citric acid, okay? Something that has a low pH. Sodium bicarbonate. Anybody know what that is? That is baking soda, okay? high pH, okay, and it's heat treated, okay? So the two things that are reacting when it hits the water, okay, is the acid and the baking soda. And we know that acid and baking soda makes bubbles. Yeah, so that's what's happening. Okay, so you see the bottle. The bottle is getting a little lopsided and it's kind of swelling a little bit. Okay, that's because of the pressure that's in there, the gas that's inside of
This
here.
step
Definitely, if you're not doing this with adult supervision, the step of opening and taking the cap off, you absolutely need an adult for. All right, let's find out if this is going to make some sound for us or not. Yeah, it's giving me a little fizz. All right, and I've got to release. Now, watch. Do you see what's happening? Okay, let me make sure that it's focused over here on Facebook. You see that the gas, right? The gas that was produced by our tablet being dissolved inside of the water is now releasing again, right? And we're getting some more bubbles there. Okay, to make sure that y'all can see that. That's just opening the bottle. I haven't done anything else. I haven't added anything else just yet, right? All I'm doing is opening the bottle. And when I open the bottle, the bubbles are released, okay? That carbon dioxide, which is the same chemical that's happening, that's dissolved inside of soda, okay? That's that same chemical that gives soda its fizz and its bubbling and its whatnot, okay? So this is it. And I do have a request for 2, and y'all know how I am. I love requests. So I will add both of them in there. Like I said, I'm not going to add the cap on because too much pressure will build up and that could damage the bottle. All right, you see what's happening? Okay. Once again, this is Miss Steph. Thank you for joining me for Science with Miss Steph. I'm getting ready to log out. I used the following materials to create this lava lamp: 3 cups, water, cooking oil, food coloring, a bottle, okay, with a top, and and our antacid tablets. I happen to use the CVS brand today because that's what's easy for me to grab, and they're cheaper, frankly, than Alka-Seltzer tablets. Okay, so does anyone? Oh, thank you. Does anyone have any questions? Any questions? Okay. I'm so used to like teaching on Zoom. Um, so yeah, so I'm so used to you being able to ask your question live where I can give you feedback. And I'm so sorry the comments didn't work on Facebook. Typically we get to go kind of go back and forth with the twins on Facebook. But hopefully next time the comments will work. And yeah, thank you so much for watching and joining me today. I'm Miss Steph. I appreciate you for watching, and I invite you to come back. Now, just so you all know, one of the DOE breaks is coming up. Okay, and so I will see you again. Yes, I will see you again right back here in 3 weeks. Okay, because there's a break. All right, and y'all know typically I take the DOE breaks. So I know I'm going to miss you. I'm going to miss you. But Miss Steph does need a break this time. So last Saturday in February, I'll come back on at 2:30 Eastern Standard Time. We'll have some fun. Now, if you want to strongly influence what I do on that day, you can you can reply to this video, right? Or you can send me a DM, a respectful DM. Okay. Or if you're on Facebook and you figure out how to do the comments, because I don't know why they're locked. Sorry. Maybe I clicked something and locked the comments. My apologies. I did not mean to do that. But yeah, you can send in your requests. And you know how it is. If I have the materials, I'll do it. Thank you for watching Science with Miss Steph. Until next time.